Variation functions. Lesson 9.5. We are skipping 9.4. Yes?
Yes.
Okay. Variation functions. Here is what you need to know. Go to the second page just because you have a lot of room to write. So I'm going to put like where it says your notes on the second page. I'm going to write down all of the information that you need in this little bubble right here. Okay? Can you follow me?
Yes.
Okay. There are 4 different types of variation. 4. The first one that you will see is direct variation. Direct variation, write that down. That is number 1, and I'll show you what this looks like, okay? Direct variation, his equation is y equals k times x. And k is a constant. What is a constant? Like a number, right? Okay, so an example of direct variation would be like circumference is equal to diameter times pi, right? Pi would be your constant, true? Because pi stays the same number. The diameter is what would be changing. So in this case, y is like your circumference and your x is like your diameter. Does that make sense? That is a direct variation. This, if you graph it, like if k is a number, if you were to graph y equals k times x, what would it look like?
A circle.
What kind of function is it? Is it linear? Is it quadratic? Is it cubic? Is it whatever? It's a linear function. Y equals a number times x. It's going to be a linear function. Linear. And it's going to be like this. I don't know. Something like that. A linear function, right?
It won't have a y-intercept,
Okay.
right?
What?
So like it won't have a y-intercept except for 0.
Now, depending on if you're doing it as a story problem. If you're doing it as a story problem, most of the time you're only going to end up with your linear function in the first quadrant. I get that. Yes, yes. So a lot of times it'll be out of story problem context and you're just solving for k or whatever. In that case, you might be dealing with all 4 quadrants. But I get it. Yes.
Right, but
story problem, a lot of times you're just dealing with like positive values in the first
Right,
quadrant.
but I'm
Got
saying like it won't have a separate intercept other than 0.
It could. Well, yes, 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 yes. Your y-intercept should be 0 because you won't have plus something on this side here. Yes. Okay, good. I got it. Okay, that is direct variation. The second one is what we've been dealing with, which is called indirect or inverse variation. Some books call it indirect, some books call it inverse. Okay, they both mean the same thing, but they are both inverse or indirect, variation. Indirect or inverse variation. There we go. And this looks like y equals k over x, like a constant divided by an x variable. Carson, Simon, are you writing this down? I don't see your eyes coming up very often. Indirect variation, y equals k over x. This would be like force equals mass times acceleration, like mass would be force over acceleration, like inverse, right? If force equals mass times acceleration and I'm solving for, let's say, acceleration, I would take the force and divide by mass to get acceleration, right? So like this has an inverse relationship, okay? Mass and acceleration has a direct relationship, but force and mass has an inverse relationship. Does that make sense? That's how that works, okay? So inverse variation, I have some constant, again, k is a constant, on the top, and I'm doing inverse variation. Now, if I graph this, y equals k over x, what does it look like? What would y equals k over x look like? This is what we were graphing yesterday.
L's and L's.
L's and L's, right? Like it will do one of those, right? Okay? And really, when we're dealing with this, check this out. Really, when we're dealing with this, most of the time we're just dealing with stuff in the first quadrant. So what's happening is as one variable is going higher, the other variable is going lower, right? Like as this gets bigger and bigger and bigger, it's going lower and lower and lower, right? Like as time moves on in the calendar year. So as we get closer and closer and closer to December, like here's January, here's December. As it gets closer to December, the number of ice cream sales goes down, right? So like ice cream sales are going to decrease as we get closer to December. That was a terrible example, but like that's an inverse relationship. As one goes up, the other one goes down.
It'd probably be like a...
Could be, yeah. I eat just as much ice cream in December as I do in wherever. But anyway, so Something like that. As one variable increases, the other one decreases. That's indirect or inverse variation. Y equals K over X. Okay, the third type.
So that one's not.
Number 3 is not linear. He is like the boomerang function, okay? Number 3, we don't usually graph number 3, but he is called joint variation, okay? And here is what joint variation looks like. It is y equals k times x times z. K is still your number, right? Okay, but y equals kxz, I have 3 variables going on. We usually don't graph joint variation just because it's in 3-dimensional space, because we have 3 variables. So we don't usually graph it, but this would be a scenario where you're doing like, I don't know, volume. Volume is equals length, width, height, or something like that, where you have multiple variables going on. Not just 2 variables, not just an x and a y. So this is called joint variation. Here's how I remember joint variation. X and z have to join together to be as big as y is. I'll say that again. Joint variation. X and z have to be multiplied together. They have to join together to be as big as y. Yeah? Joint variation. So that's what that looks like. K again is a number. Okay? So maybe you have volume of a cylinder is pi r squared h. Volume of a cylinder. I'll write cylinder. Did you know that that was volume of a cylinder? Pi r squared h, okay? The radius and the height have to join together to be as big as the volume, or to figure out the volume. What is k in this case? Pi again, right? Okay, k is your number. K is going to be your pi. What?
Is it cylinders that you like multiply by 1/3?
No, that is a cone. A cone is a third of the volume of a cylinder.
What's the
Under the same dimensions, yes. Same thing with the volume of a pyramid is a third the volume of a rectangular prism of the same dimension.
I don't know. What's
Good
the
thought.
part 4/3?
4/3 pi radius cubed is the volume of a sphere.
I was so right.
Yeah, yeah, right, very good. So whatever, anyway, so there's that. Joint variation, 3 variables. You could have more variables. You could have like 3 variables and then the 4th variable is what it's equal to, but joint variation has multiple variables. Got it? The last one, number 4, is something called combined variation.
And the other one's non-linear too? Or you just don't graph?
This one's nonlinear, yes. And this, the 3rd and the 4th one are nonlinear. Like we don't usually graph them because they're like in 3D space because they have 3 or more variables, okay? Combined variation is a combination of direct and indirect at the same time. Okay, direct and indirect at the same time. So I have y equals k times x over z. Okay, which one is the direct variable? Kx, right? Like this is my direct variable. Okay, which one's my inverse variable? Z. Do you see that? Like it's combining both of those together. So I still have 3 variables going on, kind of like I did in joint variation, but one of them is in the numerator, one's in the denominator. Good? Yes? Ish?
So is it just x the direct or is it kx?
X is the direct, k is just your constant. K is just your number. Okay? So he's not a direct variable. What?
All of these have a constant.
All of these will have a constant. Now, your constant might be 1, in which case there's no number there, right? Like, but the number is 1.
So-
But usually you'll have a constant in front.
Your
Okay?
indirect function is just y, k, z, or whatever.
So like this would be a combination of y equals k over z and y equals kx at the same time. It's like combining those two. It's a combination. Yeah? It's like shoving those 2 equations together in one. And I'm relating them together. This is like a force equals mass over acceleration type thing, but mass equals force F over A, right? Like mass in relationship to force is direct, but mass in relationship to acceleration is indirect. Confusing?
Yes.
Let's go to an example. So those are the equations that you're going to need. Let's go to example 1, which is up here, right here. Example 1 starts us off with, it gives us a lot of parts, okay? And I'm going to break this down into 3 parts, okay? All right, I'm going to put my 3 parts over here. It says, if y varies directly as x, put a line. That's part number 1. If y varies directly as x. Carson, I don't see your eyes very often. If y varies directly as x. That means I have a direct variation function, and I'm going to use y equals k times x. That's my equation. That's part number 1. I've come up with my equation. That's the first step, is knowing which equation to use. Direct variation, y equals kx. Then it says y equals -3 when x is 24. That's my second part. Y equals -3 when x is 24. Okay, I'm going to plug -3 in for y, and I'm going to plug 24 in for x. And what am I doing in the second part? I'm solving for the constant. I'm trying to find what my constant is, right? So I plugged -3 in, I plugged 24 in, and I'm going to solve for k by doing what? Divide by 24. Divide by 24. Okay, -3 divided by 24 is -1/8. And if you want to leave it as -1/8, you can totally do that. Let's just leave it as -1/8 or -0.125. That would work also. I don't care if you do it as a decimal or a thing or as a fraction. Okay, now part number 3. There's a little bit of work that I have to do before I write part number 3, and it is write your equation again with k plugged in. Now I know what k is. K is constant. K stays the same in part 2 and part 3 and part 4 and part 5. If I plug any numbers in, k is going to stay -1/8 the whole time. Okay? Now it says find y when x is -16. So find y when x is -16, right? Y equals, what's 1/8 times 16? 2. Is it positive 2 or -2?
Positive.
2 negatives make a positive, so y is +2. There we go. That's the answer. Okay? Final answer is y equals 2. Do you see how this works? Step number 1, find your equations. Step number 2, find your constant. Step number 3, solve for what they're asking for, right?
How do I know what equation to use?
They'll say direct variation, indirect variation, whatever. And it's the equations that I just gave to you.
Oh, great.
Okay?
Oh, easy.
Yeah, right?
Can you give us your homework then?
Okay? Just wait. Yes, sir.
Can you go back to the equation?
I sure can. I sure can. Now, they're also right here. This is joint variation, y equals kxc. That's joint. I don't know why they put that one first. But anyway, direct variation is y equals kx. This is direct. This is joint. Okay, also, whatever. All right, example 2. Let's go to example 2. I'll go back to the equations here in a second. Joint variation. All right, we're going to have the same 3 steps. Okay? All right, example 2 is a little bit harder just because they give it to you in the wrong order. All right, here we go. Suppose y varies jointly as x and z. And sometimes they will call them different things, so you have to be careful. Y varies jointly as x and z. So my first step, y equals kxz. That's the thing that I'm dealing with. If it said y equals varies jointly as w and v, I would change x and z to be w and v, whatever, right? That's my first equation. All right, here we go. This is backwards. Are you watching? Find, watch now. Find y when x is 4 and z is -3 if y is -15, x is -6, and z is 1.
You do the second part.
We do the if part first, right? It's giving it to you in the wrong order. Here it's giving me all of this stuff. I'm going to use this stuff to solve for k. Then I'm going to find y and plug in these other 2, right? So it's giving it to me in the wrong order, so you have to be careful. That one we're going to do the if part first. So y is -15. K stays k. X is -6. And z is 1. And this does not come out as a nice number, but that's okay. But I plugged in all my numbers. For the second part, 6 times 1 is -6, so this is -6k. I'm going to divide by -6. What is -15 divided by 6? -6? Positive 2.5?
Yes.
Positive 2.5. That's what k is. All right, now, before I start part 3, which I'm going to do down over here. I ran out of room. Before I start part 3, I'm going to go y equals kxz, but I know k is 2.5, so kxz, right? Now it says find y. Great, I'm finding y. When x is 4 and z is -3, okay? What's 2.5 times 4 times -3? -30, that's what y is, okay? So be careful. Sometimes they'll give it to you backwards. They'll give it to you in the wrong order. Good? So joint variation, this is my joint variation. Step number 2, I solved for k. Step number 3, I solved for what they're asking for. Got it? Okay, let's do another. That was example 2. This one is inverse variation and combined variation. They give them to you here. Inverse variation is k over x. Combined variation is, I don't know, on the backside.
That last one
Maybe.
is negative 30.
Negative 30, yep. All right, let's do inverse variation. They're calling it inverse. Some people call it indirect, whatever. Okay, now they're switching the names of my variables. So it says if m varies inversely as n. Normally inverse goes y equals k over x, but they're calling it m and n now. M varies inversely as n. So what's my equation look like?
M equals K over N.
M equals k over n, yeah? Okay, that's my step number 1. Now I have to solve for k. M is negative 4 when n is 6. They're giving it to me in the right order now, so I have to solve for k. M is negative 4. K is, or when n is 6. How do I solve for k? I just multiply the 6 over to solve for k. What's k going to be?
K equals negative.
Negative 24. All right, before I start, I'm going to go, m. M equals negative 24 over n. Now it says find m when n is negative 10. Find m when n is negative 10. You can do that in your head. What's 24 divided by 10? 2.4. Positive, right?
Yes.
Positive 2.4, that's what m is, okay? These are all the same steps. Write your equation, solve for k, use that to solve something else. Write your equation, solve for k, use that to solve something else. Okay, example 4, this is combined variation. Notice the wording that they use, okay? Suppose A varies directly as B and A varies inversely as C. We're combining those together, okay? So normally combined is y equals kx over z, but now I've got different variables. If A is varying directly as B,
So it would be
A is now where the y goes. X is now going to be called B, and it varies inversely as C. So C goes in for Z. So this is my equation. This is step number 1. Okay? Step number 2, I'm solving for K. It says find B. Oh, wait a second. Find B when A equals 6 and C equals 28. If B equals 7, A equals negative 49, and C equals 3. This is backwards. You got to do the third part first, right? Because it's giving me all 3 things.
If there's an if, we have to do that.
Yeah, you have to always do the if part first. Yes, yes, yes. Because really, up here we did. Oh, no, they didn't use the words if.
We did when.
Yeah, when, whatever.
When and if.
Yep, so A is negative 49. I'm solving for K. B is 7. And C is 3. All right, how do I solve for K?
Take times 3.
Times 3. Okay, what's 49 times 3? Negative 49 times 3.
Negative 147.
Negative 147. Okay, and then divide by 7. Do that in your head. What's 147 divided by 7?
11.
20.
Negative 21. 14 divided by 7 is 2. 7 divided by 7 is 1. So constant K is negative 21. All right, step number 3. Y equals negative 20. No, not Y. It's not Y. It's A. A equals negative 21B over C. All right, it says find B. Oh, crap.
Oh.
Find B when A is 6 and C is 28. Oh, man. Negative 21B over 28. Okay, how do we solve for B now?
Times
20.
28.
Times 28? It's kind of like the same steps as we did to solve for K, right?
Yeah.
28 times 6?
Can you do how you found K again?
168.
I don't know.
168, and then divide by negative 21? You can do that in your head. You can do it in your head.
6. 8.
8. Negative 8 is B.
Forgot to carry the one.
You got, yeah.
No, Colton's still in the back.
What?
Someone go check on him.
I counted him absent. They can deal with it. Hold on. We're almost done. Trevin, did you want to see how to solve for B? What? Yeah? So I plugged the numbers in for A, B, and C, right? And I'm solving for K. We multiplied the 3 over and then divide by 7.
Oh, I put in the
K is negative 21. Yeah. Okay. That was combined. And I think we have a story problem and then we're done.
No.
I like the story problem. I like the story. This is the sole reason why we do it. It's a story problem. Example 5 is a good story problem. Here we go. We can do it. What? I like the story problem. Okay, no, just wait. We're almost done. All right, here we go. Example 5. Shh. Here we go. Example 5. Shh. Example 5. A rider's speed in miles per hour varies jointly. You gotta listen. We're almost done.
Ow.
We're almost done. A rider's speed in miles per hour varies jointly. I'm going to underline the word varies. Varies jointly with the revolutions per minute of the pedals and the number of teeth on the front gear, and inversely with the number of teeth on the rear gear. What is happening? Okay, let's do some variables here. A rider's speed, should we call that S? S varies jointly with revs per minute. Okay, so let's call that R. Okay, and the number of teeth on the front gear. Let's call that teeth, T. Okay? All right, let's just start with that. We have joint variation. S varies jointly with R and T. So I need K times RT. But wait, we're not done yet. Because it says, and it varies inversely with the number of teeth on the rear gear. Over teeth on the rear gear. So let's call this F for front, and let's call this, I don't know, gosh.
So,
Let's call T sub front and T sub rear. I don't know. Holy cow, do you see that? So now I have like lots of variables going on. Okay?
so like
S was speed, R was revolutions per minute, right? Or whatever it was. Teeth on the front gear, inversely with T on the rear, teeth on the rear
so
gear.
if it was like A, B, C, would it be like A equals K, B,
BC over D.
B, C over D?
Yeah. This one is a joint and a inverse at the same time. Not a direct and an inverse at the same time.
Is there
Okay.
always three variables with joint?
Yes.
Or,
It could be more. It could be more.
Will it always be four then?
No, it could be 5 or it could be 6
Could
or
it be
whatever.
three?
Yeah.
Could it be
Okay.
less than that?
No, because then it would be direct. Right?
Like, if it was just like A equals KB over C?
That would be combined. That would be direct and inverse.
Somebody was.
All right, let's put stuff in. Here we go. Shh. Here we go. On a flat stretch of road, we gotta plug stuff in. You gotta listen. On a flat stretch of road, a rider is traveling 17.1 miles per hour. Where does that go? Speed, 17.1 miles per hour is S, okay? While using a front gear with 50 teeth, what is that going for? Teeth front is 50. And a rear gear with 16 teeth, that goes on the bottom. Pedaling at 70 RPM. That goes in for R. We're trying to solve for K, okay? So we got to solve for K first. We're going to stop that with step 2, okay? All right, multiply by 16. What's 17.1 times 16?
273.6.
273.6 equals, what's 70 times 50?
If you dig a hole, 20.
3,500 is times K. Okay, you got to watch. You got to watch, guys. If we're solving for K, we're dividing by 3,500 because I multiplied those.
Wow, 0.6.
K is equal to how much?
0.07.
No.
What?
Point
0.7.
273.6 divided by 3,500 what?
0.8.
0.078.
That's a really small number for K. Okay. Now, last thing, we have S is equal to 0.078 R teeth front over teeth rear. Holy cow.
You leave in 5 minutes.
All right, here we go. Find the speed of the rider. We're trying to solve for S. When she bikes uphill using a front gear with 34 teeth, so I'm putting 34 in for front. The rear gear has 23 teeth, and the pedaling at 70 RPM. So 70 goes there. We're just solving for S. So this guy times 70 times 34 over 23. What do you got for speed? How many miles per hour? Are we going miles per hour or do they? Yeah, miles per hour.
I don't know.
17 was in miles per hour. What do we got?
Seconds per day. How many miles is it?
8.07. Yeah.
We'll go 8.07. So 8 miles per hour.
I've gone for
Look at all that. Good? Lots of stuff going on. Lots of stuff. All right. Woo!
We have less than 5 minutes.
Give us our homework.
Jointly, inversely.
No, I don't want to.
No story prompts, please.
No, please, no story
How about we do one together in class tomorrow?
We'll make you do one story problem. 2 through 24 evens. That's only 12 problems. Page 491. 2 through 24 evens. Okay, goodbye.
Water.
Can I use the bathroom?
No, I.
Hold on just a second.